Let's take a look at the greenhouse effect. Well, we call the greenhouse effect because it works just like a greenhouse. And the way a greenhouse works is you've got your radiation coming from the sun. Well, it's high frequency. It's in the ultraviolet and visible region. High frequency, and it's short wavelength. And when it's high frequency and short wavelength ultraviolet stuff, that passes right through the glass quite easily. And then, of course, the rays come down and they're going to strike the terrain, the surface of the Earth. And the Earth's surface absorbs that radiation. But it doesn't just hang on to it, it re-emits that energy. It re-emits it at a different wavelength, at a longer wavelength. This is the emitted radiation. It's of a longer wavelength. In fact, it's in the infrared region. And infrared radiation is called heat radiation because infrared radiation is good at heating up things that are made out of water. And we're mostly made out of water, so we feel a lot warmer when there's infrared radiation around. In fact, when they first started making sun lamps so you give yourself a tan, the sun lamps were very, very uncomfortable because they were just UV radiation. And until they added some infrared radiation in there as well, it felt very unnatural because it was cold, yet it gave you a suntan or a sunburn. And it felt very kind of chemical and synthetic. When they added in the infrared to make it feel warmer, it felt much more natural. But of course, all this heat is getting trapped inside the greenhouse. So of course now it's going to be nice and warm in here. That's why your cars get so warm in the summertime. You leave the windows closed because the UV radiation gets through the glass quite easily. But then that radiation gets absorbed by the upholstery, the interior of the car, re-radiated in the infrared, and can't escape back out through the glass. So your car gets super hot. In the greenhouse effect for the Earth, it's the greenhouse gases here that play the role of the glass. So your high frequency UV and visible rays, they make it through the glass quite easily. But when it's re-emitted from the Earth, it gets re-emitted at that longer wavelength. The longer wavelength will be blocked to a large extent by the greenhouse gases. Now, it's not really being blocked. What happens is these greenhouse gases, they absorb some of the radiation and then they re-emit it. Not all of it straight back to the Earth, but in fact in all directions. But of course now there's more coming back to the Earth because of that process. But a lot of it, of course, is still going to go back out into space. And that's important. Now, usually when we say the greenhouse effect, we're thinking about bad things. We're thinking about global warming, etc. Well, the greenhouse effect is really a great, great thing because we couldn't live here on Earth if it wasn't for the greenhouse effect. It's what keeps the Earth warm. Without it, we would all die. Now, the thing that we're worried about is the enhanced greenhouse effect, and that's when there's too much of these greenhouse gases, and that increases the temperature of the Earth because too much energy is being trapped. There are four most important greenhouse gases. They all occur very naturally in our environment. The first is carbon dioxide. What's different about carbon dioxide is that because now that we're burning so many fossil fuels, we're putting a lot of extra carbon dioxide into the atmosphere. So we're all familiar with the stacks of smoke coming out of industrial areas and the exhaust coming out of cars, etc. That's heavy in carbon dioxide. And it's carbon dioxide that we feel is primarily responsible for the enhanced greenhouse effect. Water vapor is actually the most important of the greenhouse gases, but it's just part of the natural water cycle, and the amount of water vapor in the atmosphere has not increased with industrialization. Methane, well, we burn a lot of natural gas to heat our homes, etc. Natural gas is mostly methane. You might not realize it, but cows produce an enormous amount of methane. So when we're eating a lot of meat and we have a lot of cows, that means we're going to get more methane in our atmosphere. And then nitrous oxide, you might be familiar with nitrous oxide when you go to the dentist. That's an anesthetic, often called laughing gas. Nitrous oxide is being produced in large quantities in the nylon industry and also in the agricultural industry, in particular to do with fertilizers. This graph here, human sources of nitrous oxide, the large blue area here is agriculture. So most of our nitrous oxide, that extra nitrous oxide that we're putting into the atmosphere, coming from that heavy use of fertilizers. We need to be particularly concerned about nitrous oxide because it is not only a greenhouse gas, it also depletes the ozone layer. And of course, if we deplete the ozone layer, more harmful UV rays are able to penetrate the atmosphere. And of course, when we receive too many UV rays, that can cause skin cancer, etc. It's not hard to understand how these greenhouse gas molecules can absorb the infrared radiation coming from the Earth. If we go back and think about resonance when we were studying sound, we could take a tuning fork, and let's give the tuning fork a frequency, let's say F. So this tuning fork has a frequency F. We ring it, it creates a sound, and let's say these two tuning forks here, they happen to have exactly the same frequency. Then of course a little bit of that energy is going to be absorbed by these two tuning forks. They're going to start to vibrate. They will resound and produce sound in all directions. Some of that energy is going to kind of be re-emitted back to the original source. Well, it's going to work the same way with the greenhouse gas molecules. You'll have this long wavelength infrared radiation coming towards all the greenhouse gas molecules. There'll be many greenhouse gas molecules that are going to resonate at that frequency. So they're going to absorb that energy and then re-radiate it in all directions. Much of it will go out to space, but some of it's going to go back to the Earth, be trapped within the atmosphere, and help to warm the Earth. Now, of course, atoms or molecules are much more complicated than tuning forks because they have a lot more natural frequencies. Be all kinds of possible energy levels within a molecule or an atom. And so there's all kinds of frequencies that a single molecule will be able to absorb, not just one frequency like a tuning fork. And they'll also, because they're complicated enough and the energy levels are closely spaced, they can often absorb an entire range of wavelengths. So molecules have many vibrations, many energy levels, and therefore many natural frequencies. And therefore many natural frequencies that will resonate. So whenever there's resonance, that energy gets absorbed and then re-emitted in all directions. What you're seeing right now is absorption graphs for the different types of greenhouse gases. So along the x-axis here, what you're plotting is the wavelength of light. And so anywhere from here all the way to here, that's the infrared radiation, the heat radiation that will be trapped by the greenhouse gases. Now you'll notice for methane here, it has two fairly sharp peaks. So there's two resonant frequencies, two frequencies of radiation that methane will absorb quite well. And nitrous oxide here, carbon dioxide, you'll notice that it has quite a wide range where it absorbs at pretty much 100% in the low end of the infrared radiation, and then another couple of peaks here. So carbon dioxide absorbs through quite a larger range than does methane or nitrous oxide. Now, water vapor, I said that water vapor absorbs more than any of the other greenhouse gases, and you can see why here. There's a lot of frequencies here where you're getting quite large bands of wavelength that are absorbed, large bands of frequencies that are absorbed. And they're getting absorbed right up to 100% here. So that would mean that any wavelengths passing through water vapor will be 100% absorbed if they're in that frequency range. And then this is kind of a conglomerate graph here showing really the superposition of these other graphs on top of each other. So that's what the entire atmosphere does. And now I just have a few IB practice questions for you. Read over the question, try it out for yourself, come back for the answer. So what phenomena best explains why greenhouse gases absorb infrared radiation? That would be resonance. Second question, read it over, try it out for yourself, come back for the answer. Greenhouse gases, they transmit ultraviolet radiation, but they absorb infrared radiation. That would be answer D right here. So just like the greenhouse glass in a greenhouse, UV gets through, but infrared gets blocked. And a third question, read it over, try it out for yourself, come back for the answer. The role of the atmosphere in the greenhouse effect, well, the atmosphere absorbs infrared radiation from the ground. So the best answer there is B. And one final question, what I'd like you to do is to read the question over, try it out for yourself, and then come back for the answer. Okay, the first one, the mechanism by which a gas such as carbon dioxide absorbs infrared radiation. Hopefully you said something along the lines of carbon dioxide molecules have natural frequencies, or you could say energy level differences, that resonate or absorb infrared frequencies or energies. B, state with reference to your answer in A why carbon dioxide is a known greenhouse gas. Hopefully you said something along the lines of carbon dioxide is a greenhouse gas because it absorbs infrared radiation and re-emits it back to Earth. Not all of it gets re-emitted back to Earth. Some of it gets re-emitted back into space. State the name of another greenhouse gas. So I would be expecting you to say one of those three. And then finally, in the last 50 years, the amount of carbon dioxide in the Earth's atmosphere has increased significantly. Explain why this increase could account for global warming. And hopefully you said something along the lines of our increasing reliance on burning fossil fuels has increased the amount of carbon dioxide in the atmosphere so that more infrared radiation is being trapped or absorbed, and consequently the temperature of the Earth is rising. And that's all for today, folks. Thank you very much.